Okay, guys, this is going to be the video for the first video for chapter 11. We're going to be talking about factorial designs. And so this icebreaker obviously is for an in-class um, example, but if you look through this, this is getting you thinking about the idea of what we're going to end up calling main effects and interactions in the chapter. And so um, the example here is that as you go around the circle, um, the main effect would be the reactions from the people in your group to the statement, right? That's what you're looking at. But then how that person, then what they say, the types of statements that they go on to make as they go, like as each person goes around the circle, um, likely a pattern would emerge where it would be similar to the first person's example. So maybe they all end up being about broken bones, right? Because that first example was I broke my leg on my sixth birthday. Or maybe all of the statements end up being about injuries or birthdays, or or maybe the statements end up getting more and more intense as maybe each group member is trying to one up the other one. Anything like that, any kind of pattern that emerges, that's going to be an interaction, right? Because the only reason that that changed is because of what the other person said. And that's different than the people's reactions to those statements, right? So that's just kind of getting you in that mindset. The chapter objectives, there's 7 for this chapter. So here are the first 4, and here are the last 3. Hopefully you guys know by now these are in your textbook. But of course you can always screenshot these PowerPoints if that's easier for you. Okay, and so for 11.1, we are introducing you to the idea of factorial designs. So um, your chapter starts off by talking about how um, often research requires a more complex um, design, right? To mimic real life. It talks specifically about an example by Bartholo, I can't talk, and Anderson in 2002, talking about violence in video games. And they said the answer was yes and no, because um, when they threw gender in there as another variable to consider, they discovered that the females were, um, well, for the non-violent video game condition, there wasn't a difference between male and female and as far as their aggression. But when they watched the violent video game, there was a difference between males and females as far as their aggression. And so um, the what this is showing you is that if they had just looked at either both genders together, um, or if they had looked at females only or males only, they would not have seen this relationship. If they had looked at females only, it would have looked like there wasn't really a difference whether they watched a nonviolent or played a nonviolent or violent video game as far as their aggression level. If they had just looked at males, they would have said, yes, violent video games causes more aggression or leads to more aggression. But you see that neither of those statements is completely accurate. If they had looked at both genders together and had not separated them as a second variable, if they had just grouped them all together and did not look at them separately, then the averages would have changed, right? The mean numbers in your table 11.1. Well, here I can show you. Um, the these mean numbers would have changed, and so um, instead of the females and the males, the average probably would have been the same, because if you average 4.61 and 4.6, you're gonna get about 4.6, right? But if you average 5.05 and 7.01 together, you see that that's going to lower the number. It's going to be closer to 6. And so the difference between 4.6 and 6 may not be statistically significant. So you may not have seen a statistically significant difference between the nonviolent and the violent. Or you may have seen, maybe it was enough to be statistically significant. But either way, you would have assumed that in all cases, it made a difference or it didn't, when in reality, it really only made a difference for males and not for females. So you can see how sometimes it might be better to tease apart and have more variables. From a methods perspective, or research methods perspective, they used 2 variables here, game violence and gender, to create 4 groups of participants. And that allowed them to examine how aggressive behavior was influenced by 2 variables acting together. So not just game violence influencing the aggressive behavior, and not just gender affecting the aggressive behavior, but how game violence and gender are acting together to influence aggressive behavior. And again, the answer to does the violence in the video games affect the aggressive behavior, the real answer is it depends. And if the answer is it depends, then you are likely talking about a factorial design. That's a key word there. So 11.1 is talking about the first learning objective of your chapter, which is defining, identifying, and describing factorial design, of course, and also introducing you to the terms factor and level in this context. The introduction paragraph to this section reminds you that in chapters 7, 8, and 9, we talked about experimental designs, and we talked about how typically one independent variable is influencing behavior, is what we're assuming, and that one dependent variable is measuring the behavior. And so we're looking at the relationship, specifically in an experiment, the cause and effect relationship between independent variable and dependent variable. In chapter 10, when we introduced non-experimental and quasi-experimental designs, we were looking at the relationship between one quasi-independent variable and one dependent variable. So again, up to this point, we've only been talking about one variable relating to another variable. But as we just talked about in that example, variables like this rarely exist in isolation in real life. Usually there are multiple variables that are influencing behavior and things all together at one time, right? And so to understand and mimic these more complex real life situations, in order to study that, you need a research design that can do that. And so that is what a factorial design does. It is a research design that includes 2 or more factors or independent variables. So that first term that we wanted to introduce you to is a factor, which is just an independent variable in an experiment, or a quasi-independent variable in a non-experimental or quasi-experimental study. And so you heard me in some of the other chapters talking about a single factor experiment, or a single factor ANOVA, or a single factor t-test. So you've heard this word factor before. And so single factor obviously just meant we were looking at one independent variable, which is all we have looked at up to this point. But now in this chapter, you are going to start learning about designs where there are more than one independent variable, and more, so that means more than one factor. And so a 2-factor design just means it has 2 independent variables. And then again, it says right there, a single factor is what we've looked at before, which only has 1 independent variable. Going back up to the 2-factor design, that example is the gender and violent video game example we just talked about. That was a what is considered a 2 by 2 example. I mean, design. It is an example, but a design. So what that means is, if you look down at the very last thing where it says 2 by 3 by 2 with the X's in between, that is what I'm saying by for. So a 2 by 2 just means there are two independent variables and there's two levels of each independent variable. So that was gender, so male and female, and then the violent video game, so either violent or non-violent. So there's two things, and so that is what is considered a two-factor or an example of a two-factor design. Now, this last point is showing you a three-factor design. So that would be three independent variables, right? So what the heck are these numbers down here? What is this 2 by 2 stuff I'm talking about? So a 2 by 3 by 2 design there, that would mean that there's three factors, three independent variables. That's why there's three numbers. And each of those numbers is telling you how many conditions or how many levels there are for each variable. So for the first variable, there's two. So that could be gender, right? Male and female. For the second factor or second independent variable, it says there's three levels. So that could be high, medium, and low of something. They're exposed to a high level of something or a medium level of something or a low level of something. And then the last or third factor or independent variable is the two. And so there's two levels there. And so that could be a treatment versus control condition where there was some sort of manipulation and the other group did not receive that manipulation, right? And so that would be an example of a 2 by 3 by 2 design. That's what those numbers mean. So another example of a two-factor experiment is the example they use in your book. And this is the chart taken from that. I think it's figure 11.1 possibly in your study, in your textbook. And so it's showing you that in two-factor experiments, they're they usually refer to the different variables to keep track of them as letters. So factor A and factor B. So here, factor A or independent variable A is the mode of presentation of the material that they are studying. So they're either studying on paper, you see the columns, or they are studying on a screen, a computer screen of some kind. The second independent variable, or factor B, is the control or lack of control of the study time. So you see in the rows here, the first group is in a fixed time study. So they all get to study for only a certain amount of time. The second group gets to regulate themselves on how long they study. They study until they feel like they have the information down, right? In order to take the test. And so the scores would be exam scores. We would then give them an exam and see if they actually do better on the exam, if they retain the information better by studying it on paper or studying it on screen, having a set time to study, or studying on their own until they feel like they understand it. And so this right here is another example of a 2 by 2 because there's two factors, A and B, and there's two levels of each factor, either paper or screen, and then fixed time or self-regulated. Okay. Now, the advantage here for Factorial Designs is that they are more realistic, especially with variables influencing and interacting with each other, right? Again, because that is how it happens in real life more often. they don't exist in a vacuum. The variables are likely to influence each other. Using this example here, there could be an effect of paper or screen on studying. There could be an effect of fixed time or self-regulated time on studying individually. But when you combine them together, that's more realistic, because in reality, if someone is going to study, they're not just studying on paper or on screen. There's also a time factor, right? Time is also a factor in how in their studying behavior. And so if you want to know what is the most effective way to get, the most retention of the material, or the best understanding of the material, or the better exam scores, or however you want to look at it, it would be better to look at time and mode of presentation of information, right? Because those are both going to factor into how they study and how they retain that information. So the study here, if you remember from your textbook, or if you've looked at your textbook, there was no difference in this first column. There was no difference on paper whether they studied for a fixed time or they self-regulated. There was no significant difference in their exam scores. They were similar. But when it came to studying on screen, there was a difference between the fixed time and the self-regulated time. So what that means is that if we had just looked at one variable or the other, we would not have seen this relationship here, which is that when students are studying on a screen, they seem to be less able to regulate when they've studied enough, or when they've gotten good enough information. There are a lot of other factors there. They could get more distracted when they're looking on information on the screen, who knows. But regardless, it seems that their exam scores are worse when they're in charge of their own time for studying, but only when they're studying on a screen. So that's an interesting relationship, right? That we would not have seen if we had studied them each individually. The other example of that is going back to this table 11.1. Remember the study talking about gender and the violent video games on aggression. Again, just looking at females and males, you would not have seen the pattern, or just looking at the violent or non-violent games, you would not have seen the pattern. But when we look at them together, that is when we discovered that there is a difference in the violent video game affecting aggression, but only for the males, right? All right, so knowledge check. That was just a brief introduction. We're going to get into more of all of this throughout this chapter, but just to make sure you've got this information down. How many independent variables are there in a 2 by 2 by 2 factorial design? So remember the numbers there. Each number is referring to a factor or an independent variable. So since there are 3 2's there, that means that there are 3 independent variables. The 2's themselves are telling you the levels or the conditions for each variable. So remember, that means that there's 2 variables for factor A, 2 variables for factor B. I'm sorry, 2 variables, 2 conditions, and 2 conditions for factor C. So that would mean that you would have 2 conditions for your first independent variable, 2 conditions for your second, and 2 conditions for your third. And that would mean that the total down here, it tells you there would be 8 total groups, 8 total conditions, right? Because you have you multiply that 2. That's why there's an X there. It's not just first so that you can say by, it's also so that you can calculate the number of conditions you need, the number of groups you need for your study. So 2 times 2 times 2 would be 8. So you would need 8 conditions. And again, we'll get into more examples of that if that just completely is like, oh, I need a tangible example of that. We will talk more about that as we go through the chapter so that that will make more sense to you guys. So there is two other knowledge check or learning check questions. That's the one we just did. So how many separate groups of participants would be needed for a between subjects 2-factor study with 3 levels of factor A and 4 levels of factor B? Okay, let's break that down because I'm sure some of you are like, what? So if there are separate groups, because it's between subjects, so if there's separate groups for each of these conditions, each of these levels of each factor, and there's 2 independent variables here. It says 2 factors. So we have factor A and factor B, right? It shows that there. So there's 3 levels of factor A and 4 levels of factor B. So that means that there is a 3 by 4, if we're going to write it down in that notation. So 3 by 4, right? So what is 3 times 4? And that is 12. So you would need 12 separate groups or conditions for this kind of factorial design. All right, and so this last question, a researcher, I think this is the last one, yes. A researcher who is examining the effects of temperature and humidity on the eating behavior of rats uses a factorial experiment comparing 3 different temperatures, 70, 80, and 90 degrees, and 2 humidity conditions, low humidity and high humidity. So how many factors are in this experiment? Remember, factor is the same thing as independent variable. So the 2 variables that they're looking at here is, that we have conditions for, is temperature and humidity, right? We are measuring the eating behavior of the rats. So the dependent variable is the eating behavior. So we have 2 independent variables here that we're looking at, the different temperatures and the different humidity conditions. So temperature and humidity are our 2 independent variables or 2 factors. So factor A would be the temperature and factor B would be the humidity. And just to take this a step further to make sure you guys understand, factor A would have 3 conditions, right? 70, 80, and 90 degrees. Factor B, humidity, would have 2 conditions, low and high. So it would be a 3 by 2 factorial design, which means you would need 6 conditions total, 6 different groups, right, of rats. So to give you another example of how that would work, the reason you would need 6, you may be thinking, why do we multiply? Why do we need 6? So you would need a group of rats in the 70-degree low humidity condition. You would need a group of rats in the 80-degree low humidity condition. You would need a group of rats in the 90-degree low humidity condition. So that's 3. So now you also need a group of rats in the 70-degree high humidity condition, the 80-degree high humidity condition, and the 90-degree high humidity condition. So you see, you need 6 different groups because you are combining the 2 variables together. So hopefully that helps kind of give you an idea of what this whole factorial design thing is. And next, we're going to kind of flesh all this out a little bit more so that you guys can hopefully have a better grasp of factorial designs.